This production is brought to you by the University of Edinburgh.
Welcome along. In this session we're going to look at variables and how to create simple arrays such as row vectors and column vectors. Variables are an extremely important concept because they allow us to assign values to symbolic names. For example, x equals 5. Now you remember that we talked about the workspace browser in a previous screencast. And if we have a look in the workspace browser, you'll see that we have a new variable called x, and it's been given the value of 5. And the workspace browser holds all the variables that we create in the current MATLAB session. For example, I could create another variable called castle, assign a value of 12 to it, and you'll see that it now appears in the workspace browser too. Now, variables don't necessarily have to contain values. They can also contain operations on other variables. So I might create a new variable called y that's x times castle. Another way of getting information on variables in the current session is to use the whos command in the command window. And it provides very similar information to the workspace browser. It tells us the names of the variables in the current session, their size, in this case they are all scalar values, and it also tells us a little bit about how much memory space they occupy and what class of variable they are. So before we move on to looking at row and column vectors, I want to talk about two very useful commands. The first of those is the clear command, and it clears any variables that we've created in the current MATLAB session. So if I issue that, you'll notice that there are now no variables in the workspace. And for example, if I type y, MATLAB returns an error because y is now undefined. We've cleared it from the workspace. And it's always useful to use the clear command before you start a new problem or exercise. Now the second command I want to talk about is the CLC command. And it clears anything we've previously typed in the command window. So it's also useful to issue this command before you start a new exercise. Row vectors and column vectors are commonly used, and the simplest way to create them is to use the square brackets notation and to type the elements of the vectors that you want. So for example, x might be a row vector containing the elements 1, 2, 3 and 4. And we separate the elements with a space to denote that they're in separate columns. In a similar fashion, we can create a column vector y that contains 1, 2, 3 and 4. But this time we separate the elements with a semicolon to denote different rows. We can quite easily use the transpose operator to transpose a row vector to a column vector, or vice versa. So for example, I could create z, which is the transpose of x, and the transpose is denoted by the single quote. And you can see z is now a column vector. So this method of entering the elements of vectors by hand is fine if the vector is simple. But when we start defining more complicated long vectors, it becomes quite tedious. There are a couple of ways of defining longer ranges. The first of those is to use the colon notation. So I could define a row vector w that starts at 1, that goes in increments of 1, until 10. So the first value is where the vector starts, then a colon, then the increment, then a colon, and then where the vector finishes. And you can see MATLAB creates a row vector ranging from 1 to 10 in steps of 1. We can quite easily change the step size. If I use the up arrow to get my command back, I could change to a step size of 5. Now w starts at 1, it goes in a step of 5 until it reaches 10. But of course, after 6, the next element would be 11, which is greater than 10, so the vector only contains the elements 1 and 6. We can also use the increment to create a decreasing vector. So, for example, we might have the vector f, which starts at 10, counts down with a step size of 1, and stops at 5. And you see that MATLAB creates that row vector. Now there's a second way of creating ranges, but before we look at that, let's just clear up the workspace and clear the command window. And the second way of creating ranges is to use the linspace function, which stands for linear space. So I'll create a vector x that will be the linspace. It's going to start at 0. It's going to go up to 2 pi, and it's going to contain 100 elements. So the linspace function's first argument is where the range starts, which in this case is 0. We then use a comma. We say where the range stops, which in this case is 2 pi, comma, and then we say how many elements we want the range to contain. So in this case, 100. If I hit enter, my command window is filled with the 100 elements in that range. So using either the colon or the linspace function are two different options for creating ranges in MATLAB. The last thing I want to describe in this screencast is the use of the semicolon after a command. Now you'll have noticed all the commands that we've entered so far, we've entered and then pressed enter, and the result of the command is being displayed in the command window. Now sometimes we're not interested in seeing the result, and in fact the result may contain many elements that would more than fill the command window. So to stop the result printing to the command window, we can use the semicolon after our command. So if I just clear the command window and use the up arrow to retrieve my linspace command, if I add a semicolon to the end of that line now and press enter, you can see that the results are not displayed to the command window.
This production is copyright the University of Edinburgh.